Hello, welcome everybody. How are you? Today, in this video, we will know the difference between relation limited about x approximated to a 0 positive, ln x over x, and limited x belonging to infinity, ln x over x. First, we must know limited x belonging to 0 positive ln x over x. We can write 0 here in numerator and denominator. So we can write ln of 0 over 0. 0 positive. We can draw this curve about ln of x such that here. Ln 0 positive, we can going to from right hand side to left hand side to negative infinity. So ln 0 positive will be negative infinity. We can write here negative infinity over 0. The result will be what? Equal negative infinity. Again, we can write 0 here in numerator and denominator. 0 positive, then 0 positive, we can come from right hand side to left hand side to negative infinity, and we can divide it by 0 positive. Negative infinity divided 0 positive equal negative infinity, so the result will be negative infinity about this limited. And what about another relation? But in this example, we can find limited from x approximate to infinity, then x over x. The result will be infinity over infinity. To find derivative about numerator and denominator, the result will be derivative about x, and here derivative about x. So the result will be 1 over x over 1, and x belonging to infinity, we can write here infinity, so the result will be 1 over infinity over 1. The result will be 0 over 1 equal 0. 1 over infinity equals 0. Okay, so we have this function when x belonging to infinity, here 1 over infinity equals 0, 0 over 1 equals 0, and this curve about limited ln of x, so the result will be 0. Then we can find the limited about x belonging to 0 positive, the result will be negative infinity, but when x belonging to infinity, the result will be equal 0. And here we can compare between limited x approximated to 0 and tan 3 over sine x. Another limited x belonging to 0, tan x power 3 over sine x power 2. Look at here. In this example, we have tan 3x over sine 2x, and here we have tan x power 3 over x power 2. First, we can solve this example. Limited x approximated to 0, tan 3x over sine x. We can find derivative about the numerator and denominator. We can find the derivative here about x and here about x. Then the result will be, we can find limited where x belonging to 0. We can find derivative about tan will be sec power 2, and derivative about this angle will be 3 outside. We can 3 sec power 2 3x over derivative about sine will be cosine 2x, and derivative about this angle will be 2. So we can write 3 over 2 outside here and write 0 about x. We can cancel any x and write 0. So the result will be 3 over 2 outside here, sec power 2, 3 times 0 equals 0, and cosine 2 times 0 equals 0. We can find here from circle unit. Look at here, we know sec it's inverse about what? Sec it's inverse about cosine, and we have cosine here, cosine 0. We can find here this point will be 1 and 0, so we know cosine 0 will be 1, so the result will be 3 over 2 multiplied by 1 in the numerator. And what about sec? Sec is reverse about cosine, 1 over cosine 0 all power 2. Cosine 0 equal 1, 1 divided by 1 equal 1, 1 power 2 equal 1, so the result will be 3 over 2 multiplied by 1 over 1, the result will be 3 over 2. The result about limited when x approximated to 0, tan 3x over sine 2x, the result will be 3 over 2. But in this example, we want to find limited when x approximated to 0, tan x power 3 over sine x power 2. we can find the derivative about numerator and denominator about this limited. We can find derivative about x and here derivative about x. The result will be, we can write limited x approximate to 0, and we have here tan x power 3, it will be 0. We can write here about this function tan 0, but we want to find the derivative about tan. We know sec power 2. We can write sec power 2 x power 3, its angle, and approximated about this angle will be 3x power 2. And what about the numerator? Sine, the derivative about sine will be cosine x power 2, and derivative about this angle will be 2x. And then we can put 0 in this example. We can cancel in 0 in x and can write 0 here. We can write 0. 3 multiply 0 equals 0. 2 multiply 0 equals 0. 0 dot sec power 2 0 power 3 over cosine 0 power 2. The result will be 0 here and 2x cosine x power 2. First we can find 0 over 0 undefined, so we must simplify it here. We can simplify it here about x power 2 over x. The result will be 3x over 2 sec power 2 x power 3 over cosine power 2. Okay, don't do this. That not x equals 0 in example. You must simplify it first. So 0 over 0 undefined. It's impossible to find the result. 0 over 0 undefined. Okay, so 3x over 2 multiply sec power 2 x. We can write limited where x equal according to 0. So 3 multiply 0 equals 0. Multiply by sec power 2 0 power 3 equals 0, and 2 multiply by cosine 0 power 2. We know from circle unit we have 1 and 0, so cosine about 0 will be 1, and sec inverse about cosine will be 1. 1 times 0 equals 0, so the result will be 0 over 2 multiply by cosine 0 equal 1. 2 times 1 equal 1. 0 divided by 1 equals 0. The result will be equal 0 about this example. Okay, it's the difference about 2 limited. So the result here will be 3 over 2, but in this example will be 0 over 1 equals 0. And here we can combine between limited 2 operated to 0, e power 2 t subtract 1 over sine t, and what about limited e power t power 2 subtract 1 over sine t when t approximated to 0. First we can find derivative about numerator and denominator. And derivative about numerator here will be, we can find derivative numerator and denominator. Okay, and you can find the derivative about numerator about e power 2 t. We can drop 2t outside here, and we can write here, we can write e power 2t, and derivative about numerator will be 2. And what about the derivative of negative 1 equal b 0? It's about limited when t approximate to 0, and derivative about sine will be cosine. And then we can put 0, cancel any t and write 0. So the result will be 2 multiplied by e power 2 multiply 0 equals 0 over cosine 0. We know cosine 0 will be 1, so the result will be 1 in the numerator, and 2 multiply e power 0 equal 1. 2 times 1 equal 2, so 2 divided by 1 equal 2. And what about this example? Limited when t approximated to 0, e power t power 2 subtract 1 over sine t. We can find the derivative about numerator and numerator. Okay, the about t here and here about t. Okay, derivative about t. Okay, because t approximated to 0. So derivative about t. In this example, we can find approximate about this power. We can write this term e power t power 2 multiply by derivative about numerator will be 2t. Okay, the derivative about negative 1 equals 0, and derivative about sine will be cosine t. All example when t approximated to 0, we can put 0 here. 2 multiplied by 0 equals 0, multiplied by e power 0 equal 1 because 0 power 2 equals 0, e power 0 equal 1, cosine 0 equal 1, so the result will be 0 over 1 equal be what? Equal 0. We have the difference about the result about limited when e power t power 2 subtract 1 over sine t and e power 2t subtract 1 over sine t. The result here will be 2. Okay, you must know the relation about 1 and 2. What about limited when x approximated to infinity, ln of x limited when x approximated to infinity, ln of x over root of x. We must put infinity here. The result will be ln infinity over root of infinity. We know ln infinity equal infinity and root of infinity equal infinity. So infinity over infinity is undefined, so we must find the derivative about numerator and denominator for x. The result will be derivative about ln of x equal 1 over x, and derivative about root of x equal 1 over 2 of root of x. Then we can put here when x will equal to infinity, so the result will be limited. We can write limited x approximated to infinity 1 over x over 1 multiply to root of x. We can put here 1 over infinity and 1 over 2 multiply root of infinity. 1 over infinity equals 0 and 1 over infinity equals 0, so the result will be what? Here we can write 0 in numerator and 0 in denominator, undefined, so we must multiply by to simplest it here. We can write it here limited when x approximated to infinity. We can write it here 1 over x multiply the inverse about this fraction 2 root of x over 1. So we can write limited when x approximated to infinity 2 root of x over x when x approximated to infinity. So we can write here 2 multiplied by infinity equal infinity over infinity. The result will be undefined. And we can simplify it here 2 root of x over x. We can multiply root of x numerator and denominator. The result will be 2x over x root of x. We can cancel x with x. The result will be limited when x approximated to infinity. The result here 2 over root x. We can write x here 0 infinity 2 over infinity equals 0. So the result will be 0 about the example. It's okay. So you must using all properties. First, the result will be infinity infinity. We must thinking another step. Result will be 0 over 0 undefined, so we can multiply numerator and numerator. The result will be infinity, so we must in the last step we must multiply limited when x approximated to infinity. We must multiply by root of x numerator and numerator to solve it. X multiply root of x equal x root of x and numerator to x. We can cancel x with x, so the result will be 2 over root of x and x approximated to infinity. 2 over infinity equals 0, so the result will be 0.